else.
Hello, Flat Earthers. I'm weighing in on this new debate that there's a flat Earth rather than a spinning globe of an Earth. I don't know where this idea of a flat Earth reemerged since the Middle Ages, or why it has recently emerged. I don't know. But when I saw there was an international conference of the Flat Earth Society, I decided I needed to weigh in on the matter and stop the madness. So here's Robbie Davidson, a proponent of the flat
Earth. And when
Earth.
is it going to get to a point? I'm waiting for the date that they stop talking about the boats going over the horizon. Is this the best we're dealing with? I was like telling my wife, I'm like, you know what? Maybe at some point they're going to bring up this whole new stuff, and we're going to be like, whoa, where did that come in? I mean, it's been over 2 years. It's the same stuff. You know why? Because they have nothing else.
Well, I'm not a physicist or a scientist. I work in the legal field, and as such, I do understand the rules of evidence. One can never prove absolutely anything. So in law, we provide different measures of evidence. We have the probable cause evidence, which is it's 51%. It's more probable than not that this is true. Or we have substantial evidence. That's somewhere between probably more so than not and absolute reasonable doubt evidence, which is substantial evidence. And substantial evidence normally provides or requires that we accept it as generally true. Now, there is that beyond a reasonable doubt evidence. And what we say to a jury in that respect is reasonable doubt does not mean you have no doubts. You can have some doubts, but if the evidence is beyond a reasonable doubt, then you must convict. And convict is what I'm going to do. I'm going to provide a conviction that the Earth is a spinning round ball.
Today.
So let's move on. Let's listen to him some more.
Florida, the presenters, the speakers, all picked because it was important to me that people were here to represent the big picture. Sure, we have differences. We don't all agree with one another. I'd go so far as to say there's not one person that can 100% say this is the model. We don't know. We don't know 100%. But we're asking questions. And while we could be fixated on arguing about these things, but they're not even 100%. But the one thing that we're 100% on is that we are being lied to. Right? And while people are going to make so many different ways to look at this, all I'm saying is it's time to look at it of coming together and saying, look, we have our differences. We may not agree with one another. We can choose to get all wrapped on that, or we can sit here and we can be here and we can grow saying, you know what? We all agree. We're not on a spinning ball flying through space.
Well, I disagree with that. So we don't all agree, Mr. Davidson. So again, while I'm not a physicist, I can read and comprehend what I read. So when something hits me as wrong, I investigate. So what I want you to think about are two words, optics and angular momentum.
Object in front of a concave mirror.
Let's start with the term optics
one we
and
have
the
an
math
example here has
that's
a focal
required
length
to
of 25
understand
centimeters, meaning the
optics.
distance from the mirror to
This
the
is
focal point
from
is 25
the
centimeters,
physics
which means the
of
distance from the
mirrors
mirror to the
3
center of curvature
of 6
is 50 centimeters.
concave
There's our
mirrors.
object placed 15 centimeters away
Let's
from the
just
mirror, which
listen
means
for a
it's
minute.
closer to the mirror than the focal point. So here things are a little bit different. Again, we're going to find the
This
image
is
using
a
a graphical
professor
method.
discussing
that we draw
the
is parallel to the
complicated
normal.
mathematical
So we hit the mirror, it gets reflected
calculations
through the focal point,
which
and it goes
to
this way.
solve
So that's ray number
a
one. Of course,
problem
don't forget that we have an
regarding
observer.
optics
The observer's looking
and
into
what
the
we're
mirror like this.
observing.
So the little eyeball
So in
right
other
here
words,
represents our observer.
the old adage is,
The second ray that we
what
draw
you see
is from
is
the
not
object
necessarily
through the focal
what
point to the mirror.
is.
Now we have a little problem here because we're already past the focal point. So what you do then is you draw a little dotted line from the focal point
we go.
to the object, and then you continue
Oh my
on from
goodness.
there until you hit the
Isn't
mirror.
that
The mirror
crazy?
should be
Look
a
at that.
little bit longer. There we go. Now we fixed that problem. And then,
He's
of course, the ray will get reflected,
discussing
and will get
refraction
reflected parallel to the
of
normal going back
photons
this
here.
way. So this is ray
Photons,
number
as
2.
you know,
And where the two
travel
meet,
at the speed
that's
of light.
where the
And they're
image
going
is.
all which
However,
ways
the rays don't appear
but
to meet. The
they
rays
converge
seem to be diverging.
at our eye.
So there's no real
And
place
our
where
eye
they come together and form an
decodes
image. However,
the
brain
image
of this person looking at this
to
event
make
here
a
sees a ray coming
comprehensive
from this direction,
picture
sees
of
a ray
what
coming
we're
from
seeing.
this direction, and so the brain then interprets that, hey,
See?
they must both be coming
The
from
brain
this single
interprets.
point. If we then extrapolate these
So
rays
what we're
out over
seeing
here,
is not
of course,
exactly
what
what
I'm going
is.
to do here is get rid
And
of
as he
my text
discusses,
here.
what we
Getting in the
actually
way.
see is
All
virtual
right, so the brain
reality.
says, I see this ray coming
It's
from
a
back here somewhere.
photon
And I see this ray coming
image,
from back here somewhere. And what happens is the brain
which is
seems to
why
think that there is an image here causing
we
these
cannot
rays
believe
to,
what we
to
see to
diverge
be
like that.
reality.
If we now
We have to
continue
decode
drawing
it
the
in
normal
math.
past the mirror like this, and then we
There we go.
draw
Look
the
at that.
image.
Can you understand that?
There.
I can't
So
understand
this
it.
would be the image.
You can't understand it.
Now, since the image appears
But
behind the mirror,
It's
it
been
would
thousands
be a
of
virtual image.
years
It's not really
of
there,
mathematics
because images
figuring
can
out
appear behind the mirror.
the
It just seems that
mathematics
way
of optics.
by looking
And I'm not going to
at
doubt
these,
that now
these
because
rays
there's
coming from
greater
behind
masters
the mirror
than
like
me
that. All right,
that have
so
already
mathematically,
discussed this. So I
let's
feel
find
that
out
we
what
don't
the
need to go
numbers are. So first we're going
backwards
to
in
find the
time
position
by
of the
saying,
image. We
well,
have S prime
what
is equal
I
to
see
SF
is the
over
reality
S minus
and
F.
your math
This pen
is
kind of
wrong,
drying out,
which
so
is
let me grab this
what
one.
basically
Okay,
all these flat
numbers.
earthers are
Yes.
saying.
Image
I
distance,
can't
15
see
centimeters.
it,
Focal
therefore
length was
it
25
doesn't
centimeters.
exist. Well,
Image
flat
is 15
earthers,
minus the focal length
because you
25,
can't see
so it would
God,
be,
does God not
looks like
exist?
375
Well,
divided by
I don't
a minus
believe
10, which
that's
is a minus
necessarily the case.
37.5 centimeters.
So let's
All
move
right,
on.
what does that mean? The image is 37.5 centimeters.
So again, what is the speed of light? Well, here it talks of the speed of light in meters, which is difficult for me to calculate because I think in terms of miles, et cetera, et cetera. But it says the speed of light in a vacuum is, my goodness, what is this? 299,792 meters per second, a figure that physicists finally agreed on in 1975. Okay, well, you know, like I said, I don't calculate meters. Let's move on. The speed of light, as I remember it, is the speed of light 1 equals 186,282 miles per second, or in other words, it travels around, I believe, 6.7 million miles per hour. But let's just keep to a second. 186,282 miles per second. That's awfully fast. And so what you're going to have is a photon that is traveling at that speed within a container, and it's going to be bouncing that fast. And what it's going to be bouncing in, it's going to be starting to bounce in a rotating manner, And that is why I think this is the most interesting part of this whole experiment right now is this. I found this video and I fell in love with it. Thank you, Flat Earthers, because this made my day watching this video. This is an experiment. Does water swirl the other way in the southern hemisphere? Okay, the motion. Which motion are you in? Let's take a look.
To help us see where the water is flowing, I'm going to put some food coloring in on the 4 cardinal directions around the pool. Check it out, it's like a tornado, like right off the bat. We got a counterclockwise.
They're using the gravity of the Earth.
Now it's going counterclockwise.
To track
you can clearly see that the water is
the
flowing
atoms of the water
in this
as
direction,
they
and that makes
swirl.
sense because that's how it should flow in the southern hemisphere due to
Southern
the Earth's
hemisphere.
rotation.
We have a kiddie pool in my garage.
Look at it. It's
and
swirling.
The whole Earth is rotating, and the water's going counterclockwise. Because I'm in the northern hemisphere. It's real. This is real.
But you can see what a tiny little effect it is, and what extraordinary lengths I had to go to see this effect. So really, you're not going to see it in a bathtub, and you're not going to see it in a sink or in a toilet, because there are other sources of angular momentum that totally wash out this effect.
We just proved it because we just eliminated variables.
The Coriolis effect
is real.
There you have it. It works.
The next term I wanted you to remember is angular momentum. And what is angular momentum? It is what we call motion. And motion is calculated by the speed of light. And it causes everything in our universe, including every atom in our body, every atom in the earth, and every atom, as I said, in the universe, to spin and rotate. Not only does it spin, it rotates, and as it rotates at the speed of light, it creates a very interesting movement, and it's called the gyroscope movement. So let's look at the gyroscope. Here we are. Here's the calculations for the gyroscope. And what does a gyroscope do? All the forces in the universe around a central point rotate, and as they rotate, they spin. But you must remember, this is just a representation, because everything in the universe is spinning, I believe, if it is true what they taught us, at the speed of light. So we can't detect the speed of light because we are traveling at the speed of light. So everything looks like it's motionless. And that's what you call general relativity. It means that if you're in the same gravitational field, everything appears to be motionless. That is the concept of general relativity. And we might expand that too. Also, if you're in the same field of relativity, everything appears to be flat. But, that's just my take on it. Let's move on. But let's go back to the gyroscope. See? It's rotating and spinning, rotating and spinning, rotating and spinning. Okay, my point right now is that if the Earth were flat, the northern hemisphere wouldn't be rotating counterclockwise, and the southern hemisphere would not be rotating counterclockwise. They would be just stable and flat. But I want to make a certain point. Flat earthers and globalists, you're both right, because it's always one or the other or both, and I'm saying it's both. And you're going to see why in the next video. But let's just move on with this particular one, because I'm so excited about this particular experiment. So I'm going to give you a little bit more of this, and then we'll move on.
To understand how it works, imagine a pool with one edge touching the South Pole.
Think about a pool near the North Pole.
The pool is stationary relative to Earth, but every day it's actually completing one full revolution.
The Earth is spinning on its axis, so the pool spins around the pole once a day.
Now you can see the side of the pool furthest from the pole travels much farther every day than the side right next to the pole.
The whole pool is moving, but the part that's closest to the equator has more momentum, and the part that's closest to the pole has less.
So the outer side of the pool is moving fastest towards the east, and as you get closer to the pole, the velocity decreases down to zero.
Think about these velocities relative to the drain in the middle.
Now imagine we drain the pool.
When we pull the plug, all the water starts moving towards the middle.
Water from the far side is moving too fast relative to the drain, and so it gets out ahead, whereas water from near the pole is going too slow, and so it lags behind.
The side nearest the equator is going faster, so that water outruns the drain. But the water nearest the pole is going slower, so it falls behind. So when the water approaches the drain, it swirls counterclockwise. This is the reason hurricanes swirl counterclockwise in the northern hemisphere.
And this is the reason cyclones swirl clockwise in the southern hemisphere.
The center of the hurricane has lower pressure, just like a drain, so the hurricane swirls just like our pool.
Okay, the major point is that the motion at the North Pole is clockwise, the South Pole is counterclockwise. Well, what does that mean? That means there's a torsion effect of the energy. Torsion. Torsion, as explained by a certain scholar, is like when you take a Coca-Cola can and you twist it opposite directions, you're going to have a squeeze in the center of it. And from that squeeze, you're going to have a rotating like a bow tie effect. So let's go on to the second demonstration of the Coriolis or the torsion effect and why that requires the Earth to be a globe and not a flat surface at any given moment. So let's begin with this very interesting demonstration of how the Earth's rotation or torsion field works and why the Earth is round, because it's constantly spinning and rotating at the speed of light, and for all practical purposes it is a globe, but at the same time it is flat, and I'll show you that. It's called the event horizon. G can mean many things, but I say it's gravity. This is Nassim Haramein's discovery, how energy rotates within the core of the Earth and within the universe itself. This is called the torsion field effect. And as you can see, it creates a globe at the speed of light, because the speed of light basically is happening all at once. That's the Earth, but that is also your heart. It's called the event horizon, when the two fields collide. And where's the event? It's at the center. You're going to see At any given moment, yes, you are correct. There is a flat plane, but it's so infinitesimal that if it actually ever stopped, we would collapse or explode. So the motion can never stop. And the globe. But there you got it. There's the flat Earth, the event horizon at the center, where everything happens. Look at that. Beautiful, isn't it? I think it's very spiritual.